So the next part of the traverse survey is plotting of the traverse survey. Okay, plotting means what? The whatever field data you are conducted in the surveying data or by using a compass instrument, you are conducted at the field data. Maybe it will be direction or maybe it will be distances. Okay, so by using that data, we have to plot the that area with respect to collected data in the field. Okay, so that is called as a plotting of a traverse survey. Okay, suppose you are considered one small area, maybe it will be triangle, pentagon, like that. With respect to bearings and with respect to distances of the pentagon or triangle, by using that data, field data, we have to draw the diagram or area of the map. Okay, so this is called as a plotting of a traverse. Okay, so for plotting of a traverse survey, there are two principles are there. Okay, one is the angle and distance method, and second one is coordinate method. So angle and distance method means we have to measure the with respect to bearings and angles in the field, as well as a linear measurement. Linear measurement, distance between the with respect to line or with respect to points. Okay, then similarly one more it is, that is coordinate method. Okay, in these two methods, the coordinate method is the most accurate and clear method for the drawing of a traverse survey work. Okay, in that, first start with the first one, that is angle and distance method. Okay, there are three main class types are there in the angle and distance method. One is by protractor, second one is by the tangent of the scale, and last third one is by the chord of the angle. By protractor means what? The whatever the data you have collected in the field, by using a scale. Okay, 1 minute. By using a scale, we have to mark the distances by using a scale. Then the measurement of angles, we have to use the protractor, our compass instruments. Okay, that is protractor. Then make it that line with respect to angle or bearing. That is the method of the one of the angle distance method. Okay, here we are using only scale and protractor for the marking the distances as well as a angle of the with respect to line. Then second one is by the tangent of a scale. Okay, so here it is very simple. It is basically related to the trigonometrical relations. For example, this is our AB line. Okay, so if this is considered as A, this is B. So we have to measure the distance of this one. Okay, for example, this is small l or small x. Okay, so we have to draw this line with respect to that point. Okay, this is our theta. We know the theta or angle between these two lines is measured in the field. Okay, so we have to find out the distance of this one. Okay, how will find it? With respect to trigonometric relations, that is tan theta is equal to opposite divided by adjacent. Okay, so theta is here, this is opposite, and this one is adjacent. So we have to calculate this height. Okay, that is h is equal to L into tan of theta. Okay, by using that formula, we'll get the height of this formula. Okay, this one. So directly by using a scale only, we can easily mark the point of this line at a distance of h. Then later we can join the point A to the C point. Then we can easily draw the with respect to area. Likewise, we have to follow the all other points by using a tangent method. Then last one is chord method. Okay, this is also one of the geometrical method of laying off an angle. Let it be required to draw the line AD. Okay, just I will show that. Okay, this is A, this is B, suppose there is a one D point is there. Okay, so this is our AD line. We have to draw this one. So at an angle of theta. Here we don't have the any protector or any protector. Okay, so in that condition, what we have to do first, at a convenient length, we have to draw the one arc, the radius of this arc. Okay, suppose you have to draw a one arc like this. Okay, so at a center of the A point by using our compass instrument. Then later, after drawing up this arc, okay, then line, that point we have to consider, that is small b. Now B as the center. Okay, we have to draw the AD line. So that's why we have considered the at a convenient radius, that is R, A as the center, we have to draw the one arc. Okay, that is like this, one arc. Similarly, so it's also this is B point, same. You just leave this one. So again, now we have to consider the, that is B as the radius. Sorry, B as the center, R is the radius. Again, we have to draw a one more arc like this. Okay, these two arc will be meet at a one point. Then you have to join the this B point to the this point. Clear? Then later you can join the A to this arc cut point. You can extend the up to D point. Then you can find out the length of the this one, that is R dash. You can take it as a R dash. You can calculate by using a one formula, that is 2R sine theta by 2. Okay, so we can easily calculate the length of this one, that is we can take it as a this one as a small r dash is equal to 2R sine theta by 2. Okay, this is the three methods of the angle and distance methods. Okay, then second one, that is coordinate method. Okay, this is method the survey stations are plotted by using a calculating the coordinates of the with respect to points. Okay, this is the, as I told that this is the most practical and accurate one of the method for the plotting the traverse survey work. Okay, the one more advantages of this coordinate method is, in this method we can easily eliminate the closing error. Okay, we can easily eliminate the closing error by using a balancing methods. There are number of methods are there, we'll discuss in later. So the most advantages of this coordinate method is, you can any error in the our field data. Okay, suppose you have taken the one triangle. Okay, you have collected the with respect to bearings and distances of that one. After plotting up, while plotting up this triangle, the whatever starting point and the end point will not meet at a one point due to error in the collected data in the field. So if you are drawing this traverse work by using a coordinate method, so the whatever the missing or error in that is there, okay, closing error is there, so you can eliminate the by using this balancing methods. Okay, by using coordinates of the with respect to points. Okay, so in that one, there are a number of methods are there. Before that one, what are the coordinates used in the our coordinates systems? Okay, that is traverse computation. Okay. Here, first one is conjugative coordinates system. In that, we are using the two main system coordinates, that is latitude and departure. Okay, so here we have to understand the first what is the meaning of latitude and what is the meaning of departure. Okay. So coming to the latitude, a latitude of a survey line may be defined as it's a coordinate length measured parallel to an assumed meridian direction, or true north or magnetic north. Latitude means what? Latitude is the coordinate length of a with respect to line parallel to the given meridian. Maybe it will be magnetic north or magnetic meridian or true meridian. Then it is called as a latitude of the with respect to line. Similarly, departure. Departure of a survey line may be defined as it is also one of the coordinate length of the line measured at right angles to the assumed meridian. Okay, it is measured along the right angles to the assumed meridian. Then it is called as a departure of the line. Okay, so I will show here. Okay, this is the one of the figure of the with respect to that one. Okay, this one is our compass. Okay, this one is our true north. Okay, so if a coordinate length measured along the given meridian, okay, along the parallel to the north and south line, this length is called as a latitude, or that coordinate is called as a latitude. Similarly, the coordinate length is measured perpendicular to the north and south line. Okay, perpendicular to the north and south line, or parallel to the east and west. Okay, this is west, this is east. If you measure the coordinate length along the parallel to the east or east to west, or perpendicular to the north and south direction, this is called as a departure. Okay, so same here. So suppose this is a point, there is a one line is there, that is this is B point. The coordinate of this point, it is along the x direction. You have measured the, we have to measure the, that is called as a our departure. Okay, along the y axis we have to measure the our latitude, that is symbol is capital L, for departure is capital D. Clear? So for calculation of latitude and departure, there are two formulas are simple, that is L is equal to small l cos theta for the latitude. For departure, that is small l into sin theta, by using a trigonometrical relations. Just you have to observe here. So this is one of the triangle here. Our theta is here. Okay, from the north to the with respect to line. So this is opposite side and this one is adjacent side. Okay, we know the length of the AB here. So this is our departure value and this one is from here to here, it is our latitude value. So applying the trigonometric relations, our D is equal to L into sin theta. So L is equal to, latitude is equal to small l into cos theta. So you must remember these two formula for calculation of a latitude and departure. L cos theta for latitude, L sin theta for the departure. Departure is measured along the x-axis and latitude is measured along the north and south direction or y-axis. It is same as the we have to draw the our plotting of a graph. Coming to the next one, continuation of the previous one. If latitude is line is positive, okay. Similarly, the sign convention of the latitude and departure depending upon the positions of the quadrant again. Okay, if the latitude is line is measured along the towards the north line or north directions, then it is called as a northing. Okay. Similarly, if it is latitude is measured towards the south directions, okay, then it is called as a it is negative, or it is also called as a southing. Similarly, departure is it is towards the east side, it is easting, then it is in positive. Similarly, our departure is in towards the west side, then it is departure value is negative. It is same as your marking of the plus and minus sign of the graph sets along the x direction, positive x and negative x in opposite direction. Similarly, positive y, negative y in opposite direction of the along the y-axis. Okay. Along on that basis, with respect to compass angles, okay, what are the sign convention of the latitude and departure? Okay, if our whole circle bearing 0 degree to 90 degree, okay, the whatever the theta value is there, it is in between the 0 degree to 90 degree, and our RB value is it is north to east. So in that condition, our both sign convention of the latitude and departure is positive. So simply I show here, as you this is our simple graph. Okay, this is in general we are considering the y-axis. For here in the compass instrument we are considering this one is north. So this is east and this is south and this is west. In general in our graph we are taking this one as positive y-axis, negative y-axis. This is positive x-axis and negative values on the opposite of the east. Okay, same thing if it is theta is present in the in between the 0 degree to 90 degree, so there is a one point is there. Okay, the measurement of a departure and latitude value both are positive here because along the it is towards the north and the point is towards the departure measured towards the east, so both are positive. Similarly in second 90 degree to 180 degree for here second quadrant. Okay, in the second quadrant it is the angle in between the 90 degree to 180 degree. So in that condition our latitude is measured towards the south side, so latitude value will be negative and departure value will be positive. Okay, departure is measured towards the east, so that's why negative and positive. Similarly third quadrant both are negative, so in this here it is negative and this one is also negative, so our both latitude and departure will be negative. Coming to the last fourth quadrant, our here latitude is positive and departure is negative. Okay, so you must remember that one, it will help in the solving of the these sign convention in the balancing of the traverse work. Okay, then last this is same diagram I am taking for that one. So in the first quadrant latitude and departure is positive, in the second quadrant latitude is negative, departure is positive, and in the third quadrant both are negative, and last fourth quadrant latitude is positive and departure is negative. Okay, so next we have to discuss about the what is the meaning of conjugative coordinates and dependent coordinates. The latitude and departure coordinates of any point with reference to the preceding point are equal to the latitude and departure of the line joining the preceding point to the under the consideration. Such coordinates are also known as conjugative coordinates or dependent coordinates. Okay, I will discuss here. So, okay, this is the with respect to lines, length of the line they have given. This is the angles or bearings in the system of the quadrantal bearing, whole circle bearing system. And here we have written the with respect to whole circle bearing in terms of reduced bearing systems. Okay, so these are the calculation of the latitude and departure. Clear? So here the one important part is there for calculation of the latitude and departure. If you are using the theta in terms of whole circle bearing, it will directly show the with respect to sign convention of the latitude and departure. Okay, remember that one. If you have calculating the latitude and departure, in that condition, our theta value will be in the whole circle bearing system. Okay, in that condition, the whatever our calculation is calculator is there, it will show the with respect to plus or sign convention of the with respect to latitude and departure. It is not necessary to check the sign convention of the latitude and departure by observing the with respect to theta WCB or theta value. But if you are using the theta value in terms of quadrantal bearing system or reduced bearing system, in that condition, our calculator will be show the with respect to value only. It will not show the plus or sign convention or minus of the sign convention of the latitude and departure. By observing the with respect to positions of the angle, then you have to make the plus or minus sign of the latitude and departure value. Okay, so here after calculation of the L cos theta, okay, L is the length is they are given here, that is 232, and theta is we can use the 32 degree 12 minutes here. In the RB also both are same, so directly we can write it is first quadrant, both latitude and departure is positive. Coming to the second one, just I told that if you are using the WCB, okay, theta value is in WCB, this is length, okay, this is cos of the theta, theta is in WCB. In that condition, our calculator will show the with respect to sign convention. Directly we can write the minus of 1,311.02 like that, okay, with respect to value. But the same calculator, instead of theta value in WCB, if you are using the quadrantal bearing or reduced bearing system, then observe in that calculator, it will show the only value. It will not show the with respect to sign convention of the value. So after that, while entering the latitude and departure value, you have to observe the positions of the bearing, whether it is first, second, third, and fourth quadrant. Then you have to make the plus or minus sign of the with respect to latitude and departure value. So here we can directly enter the minus 111.02. In this system, directly it will show the minus sign, so you can directly enter here. If you are using the quadrantal bearing system, then you have to observe the positions of this one. It is lies in the second quadrant. In the second quadrant, our latitude value is negative, so you have to mark the minus sign of the with respect to value. Similarly, departure value in the second quadrant, departure value is positive, so I am written here plus 98.88. Similarly, you can calculate by using the L cos theta and L sin theta with respect to departure and latitude formula. We'll get the for CD line it is minus 385.54. Similarly, minus 158.90. Similarly, last plus 139.36, and last minus 329.39. Okay, these are the bearings and these are the with respect to line coordinates. Okay, this is about the latitude and departure. Coming to the one more, it is independent coordinates or total coordinates. Here, the coordinates of a traverse stations can be calculated with respect to the one common origin. Okay. The total latitude and departure of any point with respect to common origin is known as total coordinates or independent coordinates. Okay, the following this one is the our formula for calculation of the independent coordinates value. Okay, I will show the one table here. What is the total coordinates here? Okay, after the calculation of the same problem, I am data I am taken here, but I am written here with respect to line and latitude and departure, and with respect to making the sign convention, I am written the with respect to north direction and south, east and west. So in the west, in the north column, I am written here +2 latitude value. In the south line, south column, I am written here negative value. Okay, similarly, east and west, these are the positive and these are the negative value of the departure. For here, you have to assume that for the coordinate of the A point, we have to assume that is 400 here. You can assume 100, 200, whatever it is. The whatever the value you will consider, you have to make the coordinate of the A point is 400, 400. Both are same. Don't consider the 100, 200 like that. If you consider 100, so both side it is 100, 100. Okay. So now next we have to calculate the coordinate of the B point. So this is assumed 400. So for B point, our first latitude value is how much it is? 196.32. It is positive. So this value add the 400 will get the 596.32. Similarly, next east side. So here 400 is there. Our first departure value is positive. So directly we have to add the 123 to the 400 assumed value. Okay, and we will get the 523. Next, for considering the C point, okay, find out the total coordinate for the C point. So we have to consider this is the origin now for the C point. So for this 596, we have to assume consider this latitude value. This latitude value is in the south direction. So you have to use the -1, deduct this much of value in the 596, we'll get the 485.30. Similarly, it is positive, you have to add the with respect to 523.63, we'll get the 621. Similarly, same for calculation of the coordinate of this point, you have to consider the previous coordinates value. So this value, this is minus sign, we'll get the 99.76. Similarly, it is negative. So for 621 minus of 158, we'll get the 462.61. Similarly, same, you add this value and 99.76, we'll get the 239.12, and last deduct of these two value, we'll get the 132.22. By using this one, you have to plot the with respect to A, B, C, D, and E point. And next, it's closing error. Okay. Here, if a closed traverse is plotted, just I explained previous one. So what is the meaning of closing error? If a closing error or closed traverse is plotted according to the field measurements, error. Okay, closing error. First, we have to understand what is the closing error. If you have drawing a closed traverse by using a field measurements, at the end of the point of the survey traverse work will not coincide with the exactly of the with respect to starting point. Okay, so just observe here, this is the one of the closed traverse. Closed traverse means what? The whatever starting point is there, it will be act as a end point of the server will be at a end in the same point. That is A, B, C, D, E. You know that the whatever the last EA line, the whatever this point is there coincide with the starting point of the our server. If it is not coincide with the starting point, the whatever the distance between the these two points, that is A to A dash. Okay. So if you are drawing this EA line, it is end is here at the point of A dash. Okay. But our starting point is at a point of A. So the whatever distance of the A towards the A dash. Okay. This length is called as our closing error. Okay. This is our closing error. So for here, I am drawing the one vertical line with respect to points from the A dash vertical line and one more horizontal line. So I am considering this one is that is summation of the latitude values and summation of the departure values. I am considering these two because as per the rules of the closed traverse, okay, you must remember this one. In the closed traverse, the algebraic sum of the all the latitudes, it should be equal to the 0, and the algebraic sum of the all the departure, it should be equal to 0. In that condition, you come to know that the whatever the our last line is there, it is coincident with the starting point of the our server. If it is not equal to 0, then you have to come to know that there is a closing error is present. Now we have to eliminate the by using this formula, that is closing error is equal to, that is small e, that is equal to distance of A dash, that is equal to square root of summation of L square plus summation of D square. Okay. Similarly, calculation of delta value, we can use the trigonometric relation, that is tan delta is equal to summation of D divided by summation of L. Clear? It is very simple trigonometrical relation. Formulas are there for calculation of A dash. Which formula you can use that one? Simple, that is Pythagoras theorem. Okay, this is 90 degrees, so you can apply the Pythagoras theorem with respect to distances. This is A dash, this is E summation of L and summation of D. Applying that one, that is closing error. The A dash distance is, I have taken the small e, that is equal to A dash equal to square root of summation of L square plus summation of D square. Similarly, find out of the how much angle is reflected from the that point to the A point, that is delta value. We have to calculate by using a trigonometric relations, that is tan delta is equal to summation of D divided by summation of L. Put up the respective value, then simplify this one, take this tan to this side, we will get the our delta value. Then next, last is balancing the traverse. First, you have to assume that what is the meaning of balancing the traverse. The term balancing is the generally applied to the operation of applying the correction to the latitude and departure values. Okay, same as the closing error. So you must remember that one. This balancing of the traverse only applied for the closed traverse, not a open traverse. So for this one, there are number of methods are there. In that one, that is Bodice method and transit method. One more method is there, that is graphical method, and one more last, that is access method. As per your syllabus, we have two methods are there, that is Bodice method and transit method. Okay, there are simple formulas are there. First, start with the Bodice method. In this method, it is an assumption that The errors in the linear measurements are proportional to the square root of L. Okay, errors in the linear measurements are proportional to the square root of L, and the errors in the angular measurements, it is equal to the inversely proportional to the square root of L. Okay, the assumptions in the Bode's rule is linear measurements, error in the linear measurement is directly proportional to the square root of L, but in the angular measurements, it is inversely proportional to the square root of L. So here the total error in latitude and departure is distributed to the in a proportion to the length of the all the sides of the traverse. Okay, this is our in general formula, that is correction to the latitude or departure of any side, that is equal to total error in latitude or departure multiplied by length of that side divided by perimeter of the traverse. Okay. Sorry, someone is put up the mic on. Okay, thank you. So here the same formula. Okay, I am written here with respect to latitude and departure formulas. Okay, so here CL is the correction to the latitude of the any side. Okay, this is actually to CD. CD is the correction of the departure of the any side. Okay, summation of L is the total error in latitude. Summation of D is total error in departure. Then last summation of L, it is equal length of the perimeter, adding the all the length of the sides of the our polygon. So L is the with respect to line length. Okay. Similar last is transit method. Okay. In this method, the directly applying for the angular measurements. Okay, because here they are considering the angular measurements are the high precision required. Here they are measuring only applying the correction to the directly angular measurements. Okay, in this method we have to use the two instrument. One is angular, sorry, one is theodolite instrument, one more it is compass instruments. Okay. There is not much necessary here. So directly I am coming to here, that is formula of this transit method. Okay, these are the respective formula related to the latitude and departure. Summation of L means what? Total latitude, and here that is capital L written here, and with respect to latitude value you have to enter, and LT is the total arithmetic sum of the latitude. This is algebraic sum of the latitude, and this one is arithmetic sum of the latitude. Here we have to consider the with respect to sign convention of the latitude values. Here we don't consider the sign convention. Directly you have to add the all the latitude values. Similarly here same, here algebraic sum of the D, you have to consider the with respect to sign convention. For dt it is the arithmetic sum of the departures. Don't consider the sign convention of the departure, just add the all the values. So this is transit method. On that these two methods, I will solve the only one problem. The same problem we have to solve the Bode's rule as well as a transit method in the next class. So you must remember these four formula for the with respect to Bode's rule as well as a transit rule.